So let us start with question number 2. So question number 2 B part says solve the system of equations using the iterative method, accurate up to 4 significant values. So we have 3 equations: 20x1 plus x2 minus 2x3, 3x1 plus 20x2 minus x3 equals to minus 18, and 2x1 minus 3x2 plus 20x3 equals to 17. So in a Gauss iterative method, it is important that one of the coefficients should be greater than the sum of the other two. So in this, x1's coefficient is greater than the other two, in this x2 coefficient is greater, and in this x3 coefficient is greater. So what we will do is, we will put x1 on the right hand side and bring all the other things on the left hand side. So x1 equals to 17 minus x2 plus 2x3 upon 20. Similarly x2, similarly x3 we will find out. Now, for first iteration, we will put the values of x1, x2, x3 by default to 0. So when we put the value of first iteration to 0, we will find x1 value equals to 0.85, x2 value equals to minus 0.9, and x3 value equals to minus 0 plus 0.85. Now, for second iteration, we will take the values which come out of here. That is, x1 equals to 0.85, x2 equals to minus 0.9, and x3 equals to 0.85. Here we will again find out the values x1 equals to, and by solving it, we will find x1 equals to 0.98, minus 0.985, and x3 equals to 0.63. Similarly, we will repeat these steps until we found similar answers in next iteration. So in third iteration, we are finding x1 value as 0.96225, x2 as minus 1.01, x3 equals to 0.604. In fourth iteration, we are finding x1 equals to 0.961275, x2 equals to 1.0141, and x3 equals to 0.6014. And fifth iteration, we are finding x1 equals to 0.9609, x2 equals to minus 1.0141, and x3 equals to 0.60. So in this, we can see x1 as a 0.96 because here it is getting 0.96 approx. For x2, we can write it as minus 1.01, and for x3 we could write it as 0.60. So x1 will be 0.96, x2 equals to minus 1.01, and x3 equals to 0.6. So this will be our answer for question number 2b. Now let us solve the third part of our second question. Write 4 disadvantages of Gauss elimination and 3 advantages of iterative method over elimination method. So disadvantages of Gauss elimination method are complexity for the large system. Gauss elimination method can become computationally expensive and time consuming for large system of linear equation as number of variables increases, and method requires of substantial amount of arithmetic operations leading it to slower execution. Numerical instability. The method can be numerically unstable in certain cases if the coefficient of a matrix is ill-conditioned or nearly singular. Round of errors during the calculation can significantly impact the accuracy of the solution. Division by zeros. Gauss elimination method involves dividing the elements by pivot element during the elimination process. If the pivot element becomes zero, it results in a division by zero, leading to an error. Requirement of memory space. Gauss elimination method requires additional memory space because it carries argument matrix. So now advantage of iteration method over Gauss elimination method. First is applicability. Iterative methods such as Gauss, Jacobi, and Gauss-Seidel method can be extended to solve a non-linear system of equations, unlike Gauss elimination method. Efficient of efficient for sparse matrix. When dealing with a sparse matrix, when a significant number of coefficients are zero, iterative methods offer disadvantage over Gauss elimination. These methods exploit the sparsity of the matrix and reduce the computational effort as they are only considered non-element during the iterative process. Parallelizability. Iterative method can be easily parallelized, allowing modern multi-core processors or distributed computing environment. The calculation involved in each iteration can be distributed across multiple processing units, leading to faster conversions and improved overall performance. So this was our question number 2. Now we will proceed to question number 3.